Let's talk about fireworks.
Be cautious, lot of weeks smoke all the time. Till I'm nauseous, you know young get a whip. Tired of losses, I'm exhausted. I've been looking for my mind, I lost it.
Hey, what's up guys, it's What's Up?
What's up man, it's your boy Sean, and today we're here to talk to you guys about the chemical reactions in a firework.
So right here, we got a regular firework, and don't worry Miss Ryan, it's legal. Let's talk about the physical reactions of it. So as soon as you light a firework, obviously it's going to shoot flames and sparks. What's really going on is all these chemicals inside are reacting to the ignition. And pretty much when they're reacting, it's becoming exothermic because of all the heat that's coming out of it, shooting the flames and sparks.
Being exothermic, the equation is a decomposition equation, showing that the reactant is splitting up into two for the product with the use of heat. So it's decomposition because the 2-potassium nitrate is splitting up into the 2-potassium nitrite plus the oxygen, which makes a decomposition.
So what's going on in the decomposition of the firework? So what's going on in the firework is that everything is jumbled up right now. All these chemicals are jumbled up right now. They're all like contained. But as soon as you let that ignite on, which is the heat right here, this is the only way that this equation is gonna work. But as soon as you light it up, all these chemicals are exploding. Like they're all just coming out, and that's what leads it to becoming decomposition.
Conservation of matter. Conservation of matter, the law states that matter cannot be created or destroyed. So it can only be changed in its form.
So let's talk about the conservation of matter in the example of a firework. So right here we have our balanced equation, and so pretty much what's happening is that this 2-potassium nitrate is changing into a 2-potassium nitrite plus O2. But see, what you don't notice is that this 2 is multiplying by the O3. And see over here, you think that the 2 is multiplying by the O2, but it's also adding this O2. Which means that it's still, like nothing is really losing or nothing is being gained.
Exactly. So there's still the same number of elements for potassium, same number of elements for nitrogen, same number of elements for oxygen on both sides of the yield sign, similar to our model right here.
Right here is our chemical equation, and here's our model. But let's go further into the model. So right here is showing our potassium nitrates, which is also known as the KNO3s. So over here they're showing that there are 3 oxygens, 1 nitrogen, and 1 potassium. Let's move on to our potassium nitrites, where there's 1 potassium, 2 oxygens, and 1 nitrogen, which differs from our nitrate, which has 3 oxygens, and obviously our O2s. In our O2s, there are double bonds, which is also connected from the nitrogen to the oxygens, and from the nitrogen to the oxygens. Those are the only ones that have the double bonds, and everything else has a single bond.
This is our chemical equation. The type of reaction is decomposition, which is shown in our model through the potassium nitrate decomposing into potassium nitrite in our oxygens by the use of heat. Potassium nitrate decomposes through the spark, which is given in this firework, which creates the decomposition chemical reaction, which produces 2KNO2 and 2 oxygen.
And well, yeah, that's our project.
That's our project, man.
Get out of here. Man, get out of here. We done. Hey, Sean, you trying to go catch dinner?
Yeah, I'll grab Shady.
Alright.
Buddha bless this beat.
That's a fool now.